Well, generally, people come to me with a problem. They want to know how something looks like or works like. They want to know what's the mechanism.
They think of chemistry in the sense of structures that they draw on the board, that they write on paper. And with the help of these computer models, we can first of all go from 2D on paper to 3D. So we really get this extra dimension.
With our insights from our computer models, we can make it a more rational process.
It also provides a lot of relevant and useful data on the atomic scale, which is just otherwise inaccessible.
With the help of these models, of these quantum chemical models, we can understand how chemistry is happening.
Computational chemistry is just a bunch of math and physics to model and understand chemistry. And this is the best model we have of looking at things on the small scale, to look at atoms in angstrom space, and to try to understand the very pieces of things working together.
Because I can collect this data, experimental data, I can actually put it together, like in a computer. I like to say, like, I can shake it a little bit. What I can get out of it, I can really get the molecular understanding.
Say, here's a chemical, and saying, oh, that looks like this, and it might have these properties. It might be reactive in such and such a way.
I can explain why it's working or why it's actually not working. And that's where we have to engage in the conversation with the synthetic medicinal chemists to check if what my wild vision, if it's really realistic. Can it be synthesized?
We go from computer models, predictions, to experiments and results, and then go back to our computer models. And
it's really it's iterative design circle.
And this is so much information that we understand it partially. And that's really what makes it interesting. They know what they want to do, they don't know how we do it. Just this idea to think together and make things realistic on both sides is the nice thing. The knowledge just accelerates, and that's exciting.
And you are not limited by, for example, time spent in the lab or financial resources, but you can actually sort of juggle with data. But we are really at the beginning, and that's quite exciting.